this brings us to our second example problem of the day. So again, I am going to run through this example problem in the context of this lecture, but it will also be extracted. All right, so what we are looking for here, we are given the boiling point of isopropyl alcohol, which isopropyl alcohol is rubbing alcohol. So you might even have this in your cupboard, either in your apartment, your dorm, at home. It's a very, common thing that you can purchase at the store. So the boiling point of rubbing alcohol is 180.7 degrees Fahrenheit. We are asked to calculate this boiling point in degrees Celsius and in Kelvin. So we can use each of these units as a means to try and understand what 180.7 degrees means, in the context of to a person, to water, and to atoms. So at 180.7 degrees Fahrenheit, this is definitely, greater than 100 degrees Fahrenheit. This is hotter than what the average person, I would say, also a pretty arguable fair point would be all people. No one would be able to handle 180.7 degrees Fahrenheit reasonably and live. So that's where we're looking at. The boiling point of isopropyl alcohol is very high, at least to a person. So we're going to take this temperature and we are going to first convert it into degrees Celsius. What would water think of the boiling point of isopropyl alcohol? All right, so to find this, we're going to take the 180.7 degrees Fahrenheit. We are going to insert it into our equation where the temperature of Fahrenheit is. Let's see, just to write out the rest of the equation, we are going to have to solve for the temperature in degrees Celsius, and of course there is an additional plus 32 in our equation. So let's take this 180.7 degrees Fahrenheit. And also, by the way, before we're just mindlessly solving this problem, I hope you've paused the video to try this problem for yourself first, right? Brush off those algebra skills, try and solve for the degrees Celsius and Kelvin first, and then feel free to resume watching this video and check your work, see if you got it right or wrong. All right, did you pause the video? Have you unpaused the video? Welcome back if you actually paused, and if not, shame on you. Try this problem yourself. Do it. Try it. Okay, for real, we'll keep going though. All right, so let's insert our 180.7 degrees Fahrenheit in for temperature Fahrenheit. We'll just fill in the rest of the equation. It's equal to 1.8 times the temperature degree C plus 32. All right, so rules of algebra. How do we solve for our temperature in Celsius? Are we going to, we need to make sure that all numbers are on one side of the equation, we'll say the left-hand side, and our temperature in Celsius should be on the right-hand side, isolated and alone. So there are two different things that we could do. Either first, divide by 1.8 or subtract by 32. One of those methods is right and one of those methods is wrong, right? There is a place to start algebraically, and it is subtracting by 32. Yes, we have to do this first. Otherwise, if we try to divide by 1.8 first, we're actually going to end up with 32 divided by 1.8. And it's not to say that we couldn't do that. It's just normally if you divide by 1.8, you're not thinking about the leftover 1.8 that's still present on this 32. So it's just easier to subtract by 32 first, get it out of the way. And so on the left-hand side of this equation, we'll be left with a 148.7, and this will be equal to 1.8 times temperature in degrees Celsius. Now that the temperature is isolated and alone, we can divide by that 1.8 on both sides. And this is going to give us a temperature in degrees Celsius that is equal to 82.6 degrees C. All right, again, we're dusting off those algebra skills. They're going to be super useful to us for the rest of the semester. And hopefully if you attempted this problem actually as you should have done on your own, this is also the answer that you got. And if this is the answer that you did not get, hopefully by seeing my work, you kind of understand what went wrong. We can fix it for the future. All right, so the temperature in degrees Celsius gives us an idea for, from water's perspective, how hot this would feel. Now, if you were a water molecule, 82.6 degrees Celsius is going to be like lukewarm, right? Water boils at 100 degrees Celsius. That's the hottest temperature that water in its liquid form can handle. So the boiling point of isopropyl alcohol is no big deal to it. It'd be like the equivalent of us walking outside on like a 75, 80-ish degree day and being like, yeah, no, it's kind of warm, but it's doable. Like, that's exactly what's kind of happening here, only from water's perspective. All right, we are asked though to also convert this boiling point into the units of Kelvin. So let's do that as well. Again, attempt this problem on your own. Our equation is going to be the temperature in Kelvin is equal to temperature in degrees Celsius added to 273.15. Hopefully, this is a calculation that won't take you too long, so feel free to pause, run that calculation quick, and then unpause. All right, now that the video is unpaused, all you need to do is take your temperature in degrees Celsius, insert it into our equation here. This is going to give us an 82.6 degrees Celsius plus 273.15, which gives us a value equal to 355.76 Kelvin. Is this value greater than absolute zero? Yes, it is a number that is larger than zero. So what that means to an atom or a molecule is, yeah, there's considerable motion here. And so all of the units are telling us something similar, just from different perspectives.